In this video, I am going to explain the first experiment of physics 2, Charles' law. The objective of this experiment is we are going to find the value of universal gas constant R. As we already know, the standard value of R is equal to 8.314 joules per Kelvin mole. So what we are going to do in this experiment, by using this apparatus, we are going to find the value of R by experiment. And later on, we are going to compare the experimental value of R with the standard value of R. So that means the value what we are going to get should be closer to the actual value of R. So let's see what are the apparatus we are going to use here. Water bath with a thermostat heater, small piston heat engine, rubber hose, calibrated measuring cylinder, gas canister, thermometer, beaker, that's it. And all these are mentioned in this schematic diagram. But here, if you see this diagram, this is a canister. So here, in this canister, we are going to find what should be the volume of the canister. So if you want to find the volume of the canister, the first of all, we need the most important thing, the number of moles of gas present in the canister. So for this, we have to use some equation, the formula. So let's see what are the formulas we are going to use for our calculation. So if you see here, we are going to use the standard equation, which is the ideal gas equation, PV, which is equal to nRT. By using this equation, we are going to find the value of R experimentally. For this, you need the volume as well as the temperature variation, as well as we need the information about the number of moles of gas present in this canister. So if you see this diagram, if you see this picture, I show the canister picture here. So we are going to find the number of moles of gas present in the canister. So for this, we are going to use this formula, which is small n stands for number of moles of gas, which is equal to the mass of the air divided by the molecular mass of the content of the gas. So if you see in the Earth's atmosphere, by volume wise, the nitrogen holds the maximum percentage, and the second part is nothing but oxygen. So 78% of nitrogen and 21% of oxygen is the major part in the volume of the gas or air. So now for finding the mass of the air, we are going to use this equation, which is rho of air multiplied by volume. So what is this volume? So we are going to find what should be the volume of the canister. And for this, we need the data of the diameter of this canister as well as the height of the canister. So later on, I will show you the calculation. So now, by using this equation, we have to find the number of moles, and once you find, we have to substitute the value of N in this ideal gas equation for finding the value of R. So let's see what are the informations are given in the table, because from this table we are going to find the slope by drawing the graph between delta V versus delta T. So here what I'm going to do, I will show you the separate video or the video together. Maybe after I explain these things, you can see the video how to fill the data in this table. We are going to use, this is our water bath, and we have a temperature controller. Here we fixed one thermometer to measure the temperature of the water. And if you just see the temperature controller, here you can see here there are information about giving some different temperature, and this is your turn on off button switch. When you turn on, what will happen? These two lights will on, and what is the difference between these two lights? This light indicates the apparatus is working, and this light is used to check the water temperature. Suppose if you give 30 degree, the water will get heat. When you turn on, what will happen? Both light will turn on. Once the water reach this 30 degree, the second light will be turned off. That means this is an indicator. This light indicates the water temperature. Once the water reach the temperature, this light will off. So once the light will off, again you have to measure what is the temperature. Clear? So this is your water bath. This is your water bath. This is your temperature controller or water circulator. And here we fixed one thermometer. My dear, each line in the thermometer is 0.5. If you just see, each line in the thermometer is 0.5. 1, 1.5, 2, 2.5. Likewise here, 20, 20.5, 21, 22, 21.5, 22, 22.5. Like that, it will be coming. So each line in the thermometer is 0.5. And apart from that, we are going to use one calibrated measuring cylinder. You can see inside the cylinder you have a piston, and if you just see the piston value, this edge is fixed to 0. So before you start the experiment, you have to make your piston to 0. So here the readings are given. Each line here is 1 millimeter. Clear? Each line is 1 millimeter, and here you connected this cylinder with this canister, with this container. So you have to attach this canister or container along with this measuring cylinder, and here what will happen, you are going to place this canister inside after the water reaches 30 degree. So you are going to give different temperature. You are going to give 30, 35, 40, 45. So every temperature, after the water reaches the temperature, you have to dip this canister inside. When you dip this canister inside, what will happen? Whatever the temperature the water have, the same temperature is given to this canister. Inside the canister you have a gas molecule. The gas will expand when you subject to some temperature. What will happen? The gas will be passed through this tube. When the tube entered this measuring calibrated cylinder, it will push the cylinder, the piston, upward. That means for every temperature there will be change in position of the cylinder. You can see here, for every temperature the piston will be moving up, so you can find the L value from the cylinder. Okay, so these are all the apparatus today we are going to use. Let's see the table. This is your table. You are going to fill something. I'm not going to explain for all the reading. I'm going to explain for only one reading. You have to repeat the same procedure for the rest of the temperature. So if you see the table, in the top of the table we give the information about TB. What is TB? Temperature of the bath. What is temperature of the bath? This is our bath, water bath. So before you give some temperature, you have to measure what is the temperature of the water. So now I will tell you what is the value. Just a minute. Exactly, the temperature of the water is 21 degree. Exactly, the temperature of the water is 21. Each small line is 0.5. So what I am going to do? I am going to write 21 here. Clear? And then initial position of the piston. I already told you, you have to keep, before you start, you have to keep your piston to 0. That's what they mentioned here. L0 is 0 millimeter. Each line in this calibrated cylinder is 1 millimeter, not 0.1, 1 millimeter. And what is the radius of the piston? You can see here, inside there is a piston, and this piston has the radius of 16.25 millimeter. So all these informations are given. So you have to start with the temperature of the bath. We already measured. Now you have to give 35 degrees Celsius. So I am going to give this 35 degrees Celsius here. I am going to give 35 here. You can just have a look here. 30, middle is 35. So I said 35, and I am going to turn on this. If you turn on, you can see the light. Two lights are on. The first line indicates the condition of the apparatus. The second line will indicate the temperature of the bath. Once the water reaches this 35, this light will off. Clear? So let's just wait for the water to reach the temperature for that. So you can just have a look here, my dear. We said 35. Initially both light. You can see now it's on. Maybe after some time this will be off. That means once this light will be off, you consider this water will reach this 35 degrees Celsius. Just a minute. You can just have a look. The water will be immediately turned off. Not water. See this? See this light? Now it's turned off. That means the water reached the temperature. So now what you have to do, see the table. We said 35 in the dialer, and the water reached this temperature because this light is turned off, which indicates the water reached the temperature. What you have to do, you have to measure the temperature of the water again. Why? Because this controller we cannot be able to predict whether it will be giving exactly 35. Sometimes it may be less than 35,
sometimes it may be greater than 35, sometimes it may be exactly 35. It's depend upon the efficiency of the temperature controller. Okay, so now we can see again I'm going to measure the temperature of the water because we said 35. Let's see what is the value. Just show me. 31 to 33. You can just have a look here. Exactly 33. Here, my dear, I'm going to write because 33. We said 35, but 35, but we got 33. Clear? So now, once you find this TW, we have to find the change in temperature. What is the formula? TW minus TB. So what is our TW, my dear? Our TW is 33. Our TB is 21. So you have to take your calculator. 33 minus 21 gives you 12. So I am going to write this 12 here. So we finish our change in temperature. Now we have to come for L. So now I told you, my dear, the water reached this temperature. Now what I am going to do? You can just see this. I am going to take this. I am going to dip inside. I'm going to dip this inside. When I just dip this inside, you can just have a look of this cylinder. So when I just put this inside, this temperature is given to this canister. Inside the canister you have the gas, and when this temperature is given, that temperature is given to the gas will be traveled through this pipe. When it enter the piston, it will push this piston in the upward direction. Just have a look here. See here. You can just see here. My piston is rising. Small level because the temperature is small level. Am I right? So what is the value, my dear? I just tell you the value. 1, 2, 3, 4, 5. So my piston rise to 5 millimeter. Initially my piston is 0. Now it's pushed to 5 millimeter. So it is moving in the upward direction. So it's because of the temperature. So I'm going to write this value in our table. So my L value is exactly 5. So what I'm going to do, I'm going to again take this. Here we have a beaker. I'm going to put it inside. So now I'm going to write the value here. My L value is 5 millimeter. Clear? Now once you got the answer for L, you have the formula for delta L. L minus L naught. But you can see the unit. Here we measure the L in terms of millimeter. 5 minus 0, again it will be give 5, but you have to give the answer in terms of meter. So 5 minus 0 millimeter gives you 5 millimeter. If you convert this millimeter to meter, 5 multiplied by 10 to the power of minus 3 meter. Clear? So once you got this delta L, you can easily find the delta V by using this formula. What is that formula? Pi r square delta L. Pi value 3.14, r value is already given here, and delta L here. When you just work out, better I can just show you the calculation. Pi value, shift, pi value multiplied by r square. What is the r square, my dear? This is very, very important. Your r value is given in terms of millimeter. Again you have to convert this in terms of meter. If you convert, what you will get? 16.25 multiplied by 10 to the power of minus 3 meter. So I am going to use this value. 16.25 multiplied by 10 to the power of minus 3 the whole square multiplied by delta L. What is our delta L? 5 multiplied by 10 to the power of minus 3. 5 multiplied by 10 to the power of minus 3. So what should be your answer? I got 4.147. So I am going to take only 2 digit. So I am going to write 4.15 multiplied by 4.15 multiplied by 10 to the power of minus 6. So likewise, what you have to do, you have to repeat the experiment for different. So now what you have to do, you have to set 40. You can see here now it's 35, move to 40. When you move to 40, this light will start glowing. Once the water reaches 40 degree, this light will off. Again you have to measure what is the temperature of the water by using this thermometer. Once you measure, again you have to take this canister, you have to dip it inside, and you have to see what is the piston position. So likewise, you have to repeat this experiment for different temperature, and you have to fill the table. And once you fill this table, you have to draw the graph. You can just see for what you are going to draw the graph. You are going to draw the graph for delta V versus delta T. That means this is your y-axis, this is your x-axis. So I am going to draw the graph here. You have to take your y-axis here, delta V, and its unit is meter cube, and my delta T is Kelvin. And by using this value, you can see the table, all these will be your y-axis and all these delta T will be in your x-axis, and you have to use this value for fixing the point in the graph paper and connect the points with a straight line by using your ruler and choose any 2 points on the line, and this is your x1 value, this is your x2 value, this is your y1 value, this is your y2 value. So what is the slope? My slope is exactly equal to delta y over delta x. My delta y axis we took delta v, my x axis we took delta t. So the slope answer is exactly equal to delta v over delta t. The unit for delta v is meter cube and my delta t is Kelvin. So the slope unit is meter cube over Kelvin.
So let's we go for the calculation. N, which is equal to the density of the air multiplied by the volume of the canister divided by the oxygen percentage in the Earth's atmosphere, which is 21%, so 0.21%, multiplied by the molecular mass of oxygen plus the major content of the air. The by percentage is nitrogen, which takes the percentage of 78%, so 0.78 multiplied by the molecular mass of nitrogen. So once you find these things, we will easily find the value of N. So if you want to find the value of this N, first we have to find what should be the volume of the canister. As I already mentioned, for finding the canister, we need the data for the diameter of the canister. So let's we go back to the diagram, the picture. So this is our canister. So we have to get the diameter of the canister as well as the height of the canister. So here I will provide you the data for the diameter as well as the height. So if you see the diameter of the canister, the diameter of canister caps D, which is equal to 0.037 meter, and if you divide this value by 2, you will get the radius R. So here the caps R is not a gas constant, it is a radius, because we are going to find what should be the volume of the canister. So for this we need the radius of the canister. So when you divide this value by 2, you will get the value of this radius, which is equal to 0.0185 meter. So please don't get confused about the letters, because here we are going to use R for gas constant, or for radius. Even we are going to use one more R here. So inshallah you will see the clear picture in the video how to fill the data is in the table, because for finding this volume we have to use some formula, and for that also you need the radius of the piston. Clear? So don't get confused about many R's we are going to use in this calculation. So here the R here is nothing but the radius of the canister. And now if you see the shape of the canister, it is cylinder. So as we already know, the volume of the canister, which is equal to pi R square multiplied by H. So you need the height of the canister also. So the height of the canister we already measured as 0.16 meter. When you substitute the value here, so we know the value of the pi is 3.14 multiplied by 0.0185 whole square multiplied by 0.16, and when you multiply all these, you will get the value of the volume of canister, which is equal to 1.72 multiply 10 power minus 4 meter cube. Clear? So this is the calculation for finding the volume of the canister. Now what we have to do, we have to take this value and substitute here. So you have to take this value and then you have to substitute here. And also we need the molecular mass of the oxygen. As we already know, the molecular mass of the oxygen is 32 gram per mole. So we have to convert that value to kilogram per mole. So if you substitute, what you will get, N, which is equal to the density of the air is the constant, which is 1.21 multiplied by 1.72 multiply 10 power minus 4 divided by the oxygen percentage 0.121 multiplied by the molecular mass of the oxygen is 32. So 0.032 plus, and then we have to take the percentage of the nitrogen, so which is 78% as I already mentioned. So 0.78 multiplied with the molecular mass of the nitrogen is 28 gram per mole. So you have to convert that gram to kilogram, which is 0.028. When you just do the calculation for this number, you will get the number of moles, N equal to 7.29 multiply 10 power minus 3 moles. Clear? So this is our first step. Now, after we find the value of N, we have to go for the main equation, which is PV, which is equal to nRT. So here V is the variable, so P delta V, which is equal to NR delta T. So we are going to find the value of R. So you have to rearrange this equation. Therefore, R, which is equal to P multiplied by delta V divided by N multiplied by delta T. And here, delta V over delta T, you have to get the information from the graph. So after you fill the table, you have to plot the points in the graph paper for this volume as well as the temperature, and then you will get the slope. So this delta V over delta T is nothing but the slope from the graph, and then P is nothing but our atmospheric pressure, 1.01 multiply 10 power 5 Pascal, and the number of moles present in the canister. Just before we find the answer, as 7.29 multiply 10 power minus 3. Once you substitute all the values here, you will get the answer for the universal gas constant by experiment. And what's the unit? Joules per mole Kelvin. Now, after you find, we have to compare the data, the answer of the experiment R with the standard R. As we already know, the actual value of R, or the theoretical value of R, which is equal to 8.314 joules per mole Kelvin. So you have to compare this answer with your answer. And then we have to find what should be our error percentage. So how we can calculate the error percentage? The error percentage, which is equal to the absolute value of the R value by experiment minus R value by theoretical, which is our standard value, divided by R theoretical multiplied by 100. So when you substitute the value here, your answer should be between 0 to 10% of the error. That's it. Thank you.